We're very happy to present our paper on professional-level controllable transition generation for multi-shot videos. ShotDirector. Existing video generation models have made impressive progress in generating visually appealing single-shot videos. Nevertheless, generating multi-shot videos with cinematic and professional transitions remains highly challenging. In real films and professionally edited videos, transitions are not random scene switches. Instead, they are carefully designed to create smooth semantic continuity, coherent camera movement, and consistent visual storytelling between adjacent shots. However, current video generation methods usually lack explicit transition control. As a result, generated transitions are often abrupt, semantically inconsistent, or visually disconnected. This limitation becomes even more obvious when generating videos that involve complex editing styles such as shot-reverse shot transitions, cut-ins, cutouts, or multi-angle transitions. To address this problem, we propose a controllable multi-shot video generation framework that enables professional-level transition generation. Our method allows users to explicitly control the transition type between adjacent shots, while simultaneously maintaining semantic consistency and cinematic coherence across the entire video. Specifically, our framework introduces transition-aware guidance together with camera motion-related auxiliary control signals, enabling the model to generate videos with much more natural and professional transitions. Our main contribution can be summarized as: first, we propose ShotDirector, an efficient framework integrating 6-DUTF camera control and hierarchical prompting to achieve professional, film-like multi-shot transitions. Second, we combine precise parameter-level camera injection with high-level semantic guidance, enabling fine-grained manipulation of both camera movement and narrative content. Third, we introduce ShotWeaver 40K, a specialized dataset capturing professional editing priors alongside comprehensive metrics for evaluating controllable multi-shot generation. Now let's move to the method. Our framework mainly consists of two collaborative components. The first component is the auxiliary control branch for camera-related guidance. In cinematic videos, transitions are closely related to camera movement and framing changes. Therefore, instead of relying only on text prompts, we additionally introduce auxiliary control signals to guide the transition dynamics between shots. These control branches provide structural guidance regarding camera motion and shot relationships, helping the model maintain smooth temporal evolution and visual continuity during transitions. The second component is transition-aware textual guidance. Specifically, we augment the text prompts with explicit transition type descriptions, such as shot-reverse shot, cut-in, cut-out, and multi-angle transitions. By incorporating transition-aware prompts, the model learns the semantic characteristics and editing patterns associated with different cinematic transition styles. The auxiliary control branch and the transition-aware prompts work together to achieve controllable and professional transition generation. Additionally, we construct a fine-grained multi-shot video dataset for training, ShotWeaver. The dataset construction involves multiple stages of processing, filtering, and annotation. First, we collect high-quality videos containing rich cinematic editing patterns. Then, we perform shot segmentation and transition extraction to identify valid transition pairs. After that, we carefully filter low-quality samples, abrupt transitions, and semantically inconsistent shot pairs, aiming to preserve professional editing styles and strong temporal coherence. In addition, we provide detailed annotations for transition types and transition captions, enabling the model to learn fine-grained transition semantics. This dataset plays an important role in improving both controllability and transition realism. Finally, let's look at the experimental results. We first compare our method with existing baselines using several quantitative metrics. As shown in the table, our method consistently achieves superior performance in transition quality, temporal coherence, and controllability. Compared with previous methods, our generated videos exhibit better semantic continuity, more natural camera movement, and clearer cinematic editing patterns. To conclude, we propose a controllable multi-shot video generation framework for professional cinematic transition generation. By combining transition-aware prompts, auxiliary camera guidance, and a finely annotated dataset, our method enables more controllable, coherent, and cinematic multi-shot video generation.